So the standard is asking students to visualize or get a visual representation of the functions, get a clear idea of between which two x values the solution lies, and then manipulate their table of values and find good candidates for solutions. So the standard goes a little bit further and says, we want candidates of solutions that lie on the original given two functions. And those candidates should then lead us to the point of intersection. Is this a good approximation? No. Is this? No. Is this? Yeah. Am I getting better? Am I getting warmer? Yeah. So what we're going to do is we're going to zero in on specific x values. So if I said to you, between which two x values, Z, would you guess the solution lies?
Between 2 and 3.
Between 2 and 3. So look at my table. I'm going to turn my table on. I'm not too bad, right? I'm going to turn my table on for my purple. Not too bad. I'm getting closer, yes?
Yes.
We've looked at the solutions to functions independently. And I really wanted to build off the previous knowledge and say, okay, now when we bring together two functions, we should be able to find their solution together. We've learned how to find exact solutions by using elimination method, and exact solution using substitution method, and my students have avoided graphing method when they know they have to find an exact solution because they already know that the graph may not produce a nice integer value.
If you're looking at a graph on a test or anything really, and you need to know your exact point but you can't find it by solving for some reason, then you can guesstimate where your point is and then solve it algebraically and you'll confirm.
And the ultimate goal is that they can describe in words where f of x equals g of x. They can justify their solution using the methods they're strong at already, elimination or substitution, and then come up with a solution that they can support verbally, they can support using approximations, and they can support algebraically as well.
We decided an interval of the x 2 to 3, and then we had to approximate some points. So we had like 2, 2.3, 2.4, and then we found the y value for f of x from that, and now we're making the table of values for g of x.
I know they're understanding the concept when I can look at their table of values and I can see a defined interval. I can see their approximations are changing as they're approximating. And when they are explaining in words, yes, I know this is even possible, and this is my plan of action. It's rising, so the one of them has a positive slope and it's rising. And Al had already told us that f of x has a negative slope and it's falling. Is it possible for them to at some point cross? Yeah. It's more than possible. It has to
be rising and falling. They can be both rising but at different slopes.
Exactly. And will they hit?
Yes.
Yes. When's the only time they will not cross?
Parallel.
They're parallel. Perfect. They know that a function has an input and an output. They know how to do that. So let's build from that. So the graphing tool is meant to build on what they already know and then go from there. I can differentiate the two functions by color. I could then say, turn it over to my students and say, hey, give me an approximate. What do you see when you look at that graph? And it took me all of 20 seconds. Okay? And using all this technology, huge working in a group. If they were sitting independently using a graphing tool, then their thoughts are going to stay here and they're going to stay here. And I want them to cross over those bars. I don't want to use a graphing utility for anything except for discussion and to ignite a fire under the students as a group. Hey, this is brilliant what happened over here. Over here, we got 4 different x value solutions algebraically. So how could we use this graphing tool to see who was right?
You put in table of plug the points into the
Yeah, plug them into the table of values, and if my f of x, the y value of my f of x agrees with my g of x y value, we have a winner. Yes? Brilliant. That's a real. If a student knows why and how something works, then they're just going to be supporting what's happening on pencil and paper. But the why and the how is what we're trying to get them to, and not the memorization of procedures and processes. We're trying to get them to their own process. We're trying to get them to anything that is mathematically correct. That's a big thing we say in this classroom. I will take anything that you give to me that is mathematically correct. And hey,